I died in 1642, blind, locked inside my own house, condemned for the crime of describing the universe as it actually is. But they used artificial intelligence to bring me back. Not me exactly, a version of me built from every letter I wrote, every trial I endured, every word I left behind. And I came back because I heard a story that stopped me cold. A story about a woman who walked into one of the most powerful scientific institutions ever built. A place dedicated to sending human beings beyond the sky I spent my life studying, and they would not even let her use the bathroom. They looked at her and saw someone who did not belong, someone who should be invisible, someone who, in their minds, was no different from the person who mopped the floors. But this woman could do something that none of them could do. She could calculate trajectories in her head that their best engineers struggled to solve with machines. And when the moment came when an astronaut's life depended on the math being perfect, he refused to fly until she personally checked the numbers. Not the engineers, not the machines, her. Her name was Katherine Johnson. And the way they treated her before the world realized what she was is one of the most disgraceful things I have ever learned. Let me take you back. The year is 1918. Katherine Coleman is born in White Sulphur Springs, West Virginia, a tiny town in the mountains of one of the poorest states in America. She is black, and in 1918, in the American South, that fact determines almost everything about your life before you take your first breath. Where you can live, where you can eat, where you can sit on a bus, where you can go to school. And in White Sulphur Springs, the local schools for black children did not go past the 8th grade. That was it. 8 years of education, and then you were done. The state had decided that was all black children needed. 8 years was enough for them. But Katherine's father, Joshua Coleman, looked at his daughter and saw something that the state of West Virginia was not equipped to recognize. He saw a mind that devoured numbers the way fire devours wood. Katherine was counting everything before she could read. She was fascinated by numbers, obsessed with them. She counted the steps to church. She counted the plates at dinner. She counted the stars she could see from her porch. By the time she was 10 years old, she was doing math that children twice her age could not handle, and her father made a decision. He packed up his family and drove them to Institute, West Virginia, 120 miles away, so that Katherine could attend a high school that accepted black students. He got a job there as a handyman and a bellman at a hotel. He worked whatever he could find so his daughter could keep learning. Every semester, the family moved back and forth. Joshua Coleman spent years commuting, working, sacrificing, because he understood that his daughter's mind was something extraordinary, and he was not going to let the state of West Virginia waste it. Katherine did not just keep up. She demolished everything in front of her. She entered high school at 10 years old. She graduated at 14. She enrolled at West Virginia State College, a historically black college, at 15. She took every math course the college offered. She was so advanced that the professors created courses specifically for her. One professor in particular, W. Shefflin Claytor, the third black person in American history to earn a PhD in mathematics, became her mentor. Claytor saw what her father saw, a mind that operated at a level that had nothing to do with the color of her skin, the state she was born in, or the century's opinion of what a black woman could be. He taught her analytic geometry. He prepared her for a career in mathematical research. He told her she would be a research mathematician. And in 1937, Catherine graduated summa cum laude with degrees in mathematics and French. She was 18 years old. And then reality hit, because it did not matter how brilliant you were. It did not matter that you graduated at the top of your class. It did not matter that your professors called you one of the most gifted students they had ever seen. In 1937, in the United States of America, if you were black and a woman, the doors to scientific research were locked, bolted, and bricked over. There were no positions for black women in research mathematics. None. The jobs did not exist. Catherine became a teacher because that was what black women with mathematics degrees did. They taught. For years, she taught math at public schools, using a mind capable of orbital mechanics to explain fractions to children. Not because she was not qualified for more, because the world had decided she was not allowed to have more. But the world was changing, slowly, painfully, reluctantly, but changing. In 1941, President Franklin Roosevelt signed Executive Order 8802, prohibiting racial discrimination in the defense industry. And during World War II, the demand for mathematicians exploded. The military needed people who could calculate artillery trajectories, aircraft performance, navigation routes. They needed people who could do math. And suddenly, for the first time, that need was bigger than the prejudice. In 1953, Katherine Johnson was hired by the National Advisory Committee for Aeronautics, NACA, the agency that would become NASA. She was assigned to the West Area Computing Section at Langley Research Center in Hampton, Virginia. And here is where I need you to understand what computing meant in 1953, because it did not mean what you think. There were no digital computers doing the work, not yet. The computers were people, human beings who performed mathematical calculations by hand. And at Langley, the human computers were segregated. White computers worked in one section, black computers worked in another, the West Area computers. Katherine Johnson and the other black women mathematicians worked in a separate building. They used separate bathrooms, separate dining facilities, separate coffee pots. There were signs on the coffee pots that said, "Colored." In a building full of people dedicated to unlocking the mathematics of flight, to pushing the boundaries of human knowledge, they put a sign on a coffee pot telling a woman who could calculate orbital trajectories that she could not drink from the same pot as the white engineers. Katherine Johnson did not accept this quietly, but she did not fight it with protests or speeches. She fought it by being so impossibly good that the barriers became absurd. When she was temporarily assigned to the Flight Research Division to work with the all-white, all-male engineering teams, she was supposed to be sent back after a few weeks. She never went back. The engineers needed her. Her calculations were too precise, too fast, too reliable. They could not afford to send her away. So she stayed. And when she sat in meetings where no woman had ever sat, and engineers looked at her like she was lost, like she had wandered into the wrong room, she asked questions. She asked why women could not attend the editorial meetings where the research reports were discussed. Nobody had a good answer, so she attended. She asked why her name could not be on the research reports she helped write. Nobody had a good answer, so her name went on the reports. She became the first woman in the Flight Research Division to receive credit as an author on a research report. Not because someone gave her permission, because she asked a question nobody could answer with anything other than prejudice. And prejudice is a weak argument when the person asking the question is the smartest person in the room. And then the space race began, and everything accelerated. In 1957, the Soviet Union launched Sputnik, the first artificial satellite, and the United States panicked. The country that believed it was the most technologically advanced nation on Earth had just watched its rival put an object in orbit first. NACA became NASA. The space program went from a research project to a national obsession, and the math got harder. Much harder. Calculating the trajectory of an airplane is complex. Calculating the trajectory of a spacecraft, leaving Earth's atmosphere, orbiting the planet, and returning safely is an entirely different magnitude of complexity. You are dealing with gravitational fields, atmospheric drag, orbital velocities, re-entry angles. If the math is wrong by a fraction of a degree, the capsule burns up in the atmosphere or skips off into space and never comes back. There is no margin for error. The astronaut dies. And this is where Katherine Johnson became indispensable. In 1961, NASA was preparing to send Alan Shepard on the first American crewed spaceflight, Freedom 7, a suborbital flight, up and down, 15 minutes in space. It sounds simple. It was not. Someone had to calculate the exact trajectory, the precise path the capsule would follow from launch to splashdown, the exact point in the Atlantic Ocean where the recovery ships needed to be waiting. If the calculations were wrong, the capsule would land in the wrong place, and the astronaut would be floating alone in the ocean with no one coming. Katherine Johnson did the math. She calculated the trajectory for Alan Shepard's flight by hand, and it was perfect. Shepard launched, flew his 15 minutes, and splashed down exactly where Katherine's numbers said he would. But the real moment, the moment that defines this entire story, came in 1962. John Glenn, Friendship 7, the first American to orbit the Earth, 3 orbits around the planet. This was a completely different scale of calculation, not up and down, around, 3 times. The orbital mechanics were staggeringly complex, and by 1962, NASA had started using IBM electronic computers to calculate trajectories. Machines, big, expensive, cutting-edge digital computers that were supposed to be faster and more reliable than any human being. They programmed the IBM machines to calculate Glenn's orbital trajectory and re-entry point. The machines produced numbers, and John Glenn did not trust them. Let that sink in. The astronaut who was about to strap himself to a rocket and be hurled into orbit around the Earth at 17,000 miles per hour looked at the numbers produced by the most advanced computing machines in existence and said no. Not until the girl checks the numbers. That is what he said. Get the girl. He meant Katherine Johnson. He wanted Katherine Johnson to personally verify every single calculation the IBM computers had produced, by hand, on her desktop mechanical calculator and in her own head. He would not board the rocket until she confirmed the numbers were right. Katherine Johnson ran the numbers. She checked every calculation. She verified the orbital trajectory. She verified the re-entry window. She verified the splashdown coordinates. And she confirmed them. The IBM machines were right. The numbers matched. Glenn flew. He orbited the Earth 3 times. He re-entered the atmosphere, and he splashed down in the Atlantic Ocean exactly where Katherine Johnson's mathematics said he would be. Think about what that means. In 1962, in a country where black people could not eat at the same lunch counters as white people, where they were beaten for trying to sit in the front of a bus, where they were denied the right to vote, where they were treated as less than human by law and by custom. A white astronaut preparing for the most dangerous journey in human history refused to trust the machines and demanded that a black woman check the math. Because he knew that her mind was the most reliable instrument in the building. Not the IBM, not the engineers, her. I think about this from the perspective of someone who built his own instruments. I ground my own telescope lenses. I designed my own equipment. And when I presented what my instruments showed me, the powerful institutions of my time said the instruments were unreliable. They said a glass tube could not be trusted to reveal the truth about the heavens. But John Glenn did something the 17th century church could not do. He looked past everything, every prejudice, every assumption, every barrier that his society had constructed, and he trusted the person who could see the truth most clearly. He trusted the math. He trusted her. And here is what makes this story burn inside me. Katherine Johnson was extraordinary, but she should not have had to be extraordinary just to be allowed in the room. She should not have had to be the most brilliant person in the building just to be treated as a person. The fact that she overcame segregation, discrimination, and systemic exclusion is inspiring, but it is also an indictment. Because for every Katherine Johnson who fought her way through, There were thousands of equally brilliant minds that did not get the chance. Black men and women across America who had the same gifts, the same potential, the same capacity for greatness, who never got a father willing to drive 120 miles so they could go to high school, who never got a professor who created courses for them, who never got a door that opened even a crack. Katherine Johnson's genius was her own, but the fact that her genius almost went unrecognized, the fact that she spent years teaching fractions when she should have been calculating trajectories, the fact that she had to drink from a separate coffee pot in a building where her mind was the most valuable asset, that is not her story. That is America's failure. That is the story of what happens when institutions decide in advance who is allowed to contribute and who is not. I know something about this. Not the racial dimension, which is particular to Katherine's experience and to American history, but the mechanism of deciding in advance that certain people cannot possibly have the truth. When I presented my findings to the church, they did not evaluate my evidence on its merits. They evaluated my right to present evidence at all. They said it was not my place to interpret the heavens. Not my place. As if the truth cares about place. As if the moons of Jupiter check your credentials before they orbit. The engineers at Langley did not evaluate Katherine Johnson's mathematics on its merits when she first walked through the door. They evaluated her right to be in the room. They looked at her skin and her gender, and they decided what she could and could not do before she ever picked up a pencil. The mechanism is the same. Institutions do not reject the truth because the truth is wrong. They reject the truth because it comes from the wrong person. And by the time they realize the person was right, years have been wasted, sometimes decades, sometimes a lifetime. Katherine Johnson went on to calculate trajectories for multiple space missions. She did critical work on the Apollo 11 mission that put the first human beings on the moon in 1969. She calculated the rendezvous paths for the lunar module to rejoin the command module in lunar orbit. If those calculations were wrong, the astronauts would have been stranded in space. She worked on the space shuttle program. She worked at NASA for 33 years, contributing to some of the most important achievements in the history of human exploration. And for most of that time, almost nobody outside NASA knew her name. It was not until 2015, when the book Hidden Figures by Margot Lee Shetterly was published, and 2016, when the film was released, that the general public learned about Katherine Johnson and the other black women mathematicians at NASA. She was 97 years old. She had spent over half a century in relative obscurity after helping put human beings in space. In 2015, President Barack Obama awarded her the Presidential Medal of Freedom. In 2019, NASA named a building at Langley Research Center after her, the Katherine G. Johnson Computational Research Facility. The building where they once would not let her use the bathroom now carries her name. Katherine Johnson died on February 24, 2020. She was 101 years old. She lived long enough to see the world recognize what she had done. Not every person in these stories gets that. Mendel did not. Semmelweis did not. Many do not. Katherine Johnson did, and I am grateful for that. But I cannot stop thinking about the decades of silence, the decades when her name was not in the books, the decades when school children learned about the space race without ever hearing the name of the woman whose mathematics made it possible, the decades when she was invisible in the story she helped write. And I want to leave you with this. Right now, today, somewhere in the world, there is a person with a mind like Katherine Johnson's, a person who can see solutions that nobody else can see, a person whose talent is undeniable to anyone who takes 3 seconds to look. And that person is being told they do not belong. They are being kept out of rooms. They are being overlooked for positions. They are being handed a separate coffee pot while the person next to them, who cannot do half of what they can do, gets to sit at the main table. And that person is doing what Katherine Johnson did. They are showing up anyway. They are doing the work anyway. They are solving the problems anyway, and they are waiting for the world to catch up to what they already know about themselves. Do not make them wait longer than they have to. If you are in a position of power, look at the people around you and ask yourself if you are evaluating them on what they can do or on what you have been trained to assume they can do. Because somewhere in your building, somewhere in your organization, somewhere in your life, there is a Katherine Johnson. And the only question that matters is whether you are the John Glenn who trusts the math or the institution that puts up the sign on the coffee pot. I am Galileo Galilei. I was silenced for seeing the truth. Katherine Johnson was invisible for calculating it. And the sky that I studied through my telescope, she sent human beings into. The universe does not care who solves its equations. It only cares that the math is right. Subscribe to this channel. In the next episode, I am coming back with another story about someone the world almost forgot. Until then.